Namaskar my dear friends. Let us talk about integration. So in mathematics you would have seen integration of, let us say, f of x dx is capital F of x plus some constant c. For example, you already know integration of x dx is x square by 2 plus some constant c. So we'll try to understand how there are different kinds of integrations and how we can solve them very easily. So what we'll see in this particular sessions is we'll try to understand integration as a inverse process of differentiation. Like you know already differentiation, so we will be able to find out integration as the inverse process. Then we will see integration properties, okay, and then we will also see some basic integrations on that problems, okay. Then we'll proceed with methods of integrations. Like let us say first of all we'll understand integration by substitutions. Then we'll see problems on substitutions as well. Then we will see integration using trigonometric identities like sin theta, cos theta, tan theta, all these things are there. So trigonometric identities are very important. We'll go ahead with some particular functions like let us say in like a square root function or something like that. Then we will see integration by partial fractions. This is one of the very important part. Then we will see integration by parts, which is like let's say UV form, integration of UV dx. So how to integrate by parts. There are different kinds types of integrations like exponential integrations or like very particular functions. So those types also we will see, and we will have more types of integration, that also we'll see. Then we'll proceed with definite integral. Definite integral, basically we will be having limit, let us say 1 to 2 x square dx. Then what will be the answer? Okay, so we'll see in definite integrals like fundamental theorem of calculus, evaluation of definite integral by substitutions, and some properties of definite integral, so that you can solve it very quickly. Then application of integrals as well we will see, like how can we like what are the different applications of integral, how can we find out area of a particular curve using integral. Then there are a lot of improper integrals. We'll see improper integrals, we will see line integration. Then we'll go ahead with Green's theorem, Stokes theorem, divergence theorem. Then there are multiple integrations are there, okay. And at last I'll just give you a particular understanding about beta and gamma functions, okay, and their properties. So to understand integration, what we'll first do is we'll try to see some of the formulas for differentiation. So that will be called as derivative also. So once we understand derivative or differentiations, we will be able to apply this as a inverse property of derivative. So let us say first formula I will just try to give you is differentiation of d by dx of x to the power n, okay. So you know already n x to the power n minus 1, okay. So what happens is the coefficient comes at the like beginning, and then power reduces by 1, okay. So for example, if I give you d by dx of x to the power 3, then it will become 3x to the power 3 minus 1, that is 2, okay. Once you understand complete formulas of derivative, then we'll go ahead with integration. It will be very easy. Or in particular like you can do d by dx of x, so that is going to be 1. Why? Because 1 into x to the power 1 minus 1, that is 1 into x to the power 0, that is 1, okay. So this is how d by dx of x. Let us say make it just 2 d by dx of sin x. So sin x is cos x. So we'll see integration of cos x will become sin x. Like that is the like definitions we'll try to understand. Then we'll see d by dx of cos x. So that will become minus sin x. So integration of minus sin x will be cos x. That we will also see that. Then we'll see, let's say fourth one, differentiation of tan x. So that is going to be sec square x. sec square x. Let us try to take next one. We have fifth one as d by dx of cot x. So 10x is done, cot x will be minus cosec square x. So integration will be just opposite to that, like integration of minus cosec square will become cot x. Okay, so that's the main understanding that I want to give it to you. Differentiation of sec x. So that will be sec x into 10x. You just have this as very good understanding, like what are the different differentiations. This will also be very helpful in various areas. Okay. Next is d by dx of cosec x. So we have seen almost all the trigonometric now. So that will become minus cosec x into cot x. Let us see some inverse functionals. So let me just number this as 6, then 7. 8th will be d by dx of sine inverse x or sine to the power minus 1 x. So that is going to be 1 by a square root of 1 minus x square. 9th number will be d by dx of cos inverse x. Cos inverse x. So that will become minus 1 by a square root of 1 minus x square. Then we will see, let's say 10th one, differentiation of 10 inverse x. That is going to be 1 by 1 plus x square. Very important formula. This is used almost everywhere. Okay. What will be the next one? D by dx of 10 and then cot it will become, right? Cot inverse x. That will become minus 1 by 1 plus x square. So sine cos 10 cot, like that you can try to understand. Okay. 12th one will be differentiation of sec inverse x. Sec inverse x. That will become 1 by x root under 1 root under x square minus 1. Next one will be d by dx of cosec inverse x. That will become 1 by x root under x square minus 1. However, what will be the change from sec inverse x and cosec inverse x? So there will be negative sign. Next is, let's say we are remaining with exponentials. So we can see, let us say this will be my 14th one. Differentiation of e to the power x will be e to the power x only. Okay. I'll write it like this. Then we can go ahead with log also. So differentiation of log x, just understand that in mathematics we will be using log, means always it will be base e or exponential base, right? So that will be 1 by x. Then differentiation of a to the power x, instead of e to the power x it will be a to the power x. So a to the power x will be a to the power x into log a. Okay. So this was all about, like differentiation formulas. Now just the opposite of this or inverse of this will become my integration. So you can see, for example, I'll just tell you one of them and then we will proceed with all the integration formulas. So if I tell integration of a to the power x log a, dx. So that will be what? This value. So this is going to be a to the power x. And then from here we will try to standardize this formula. Then what will happen? Integration of a to the power x dx is going to be a to the power x, and log a will become this side. So it will become log a. So it means as a inverse process of like differentiation, integration becomes very easy because we already know the differentiation of a to the power x. So integration of a to the power x will be very easy. So let us talk about integration formulas one by one. So number one will be, let us say, integration of x to the power n dx. So we had seen differentiation of x to the power n, now integration of x to the power n. So what will become? X to the power n plus 1 divided by n plus 1 plus some constant c. Okay, so some constant c will always be there. Okay, and make sure n must not be equal to minus 1. What I mean to say is, if n becomes minus 1, then minus 1 plus 1 it will become 0. So something by 0 will be not defined, or infinity. So that's the problem, right? Then number second, integration of dx, like 1 dx or dx, that's it. So this will become x plus c. Or you can see like this also, differentiation of x dx. So that will be what? This formula you can utilize, x square by 2 plus c, because x to the power 1 plus 1 that is 2 divided by 1 plus 1 that is 2. So similar to that you can extend for any of the powers. Okay, third one will be integration of, let us say, sin x dx. So that will become minus cos x dx, minus cos x plus c. Then integration of cos x, that will become sin x plus c. So you see, sin x becomes minus cos x and cos x becomes just sin x. Okay. Then let us say fifth one, we will see integration of sec square x dx. So that will become 10x plus c, because differentiation of 10x was sec square x. Okay, now integration of, let us say, cosec square x, that will become minus cot x plus c. Next one will be integration of sec x 10x, that will become just sec x plus c. So you can see differentiation of sec x was 10x sec x 10x, right? So integration of sec x 10x will become sec x. Integration of my cosec x is, that will become minus cosec x into cot x. Then next one will be integration of some other like formulas that we had seen. What was that? Integration of dx by root under 1 minus x square. Okay, so what will happen? This was sine inverse functions, right? So sine inverse x plus c. Next is integration of let's say minus dx if you want to do, or otherwise what will happen is two things are there. One was sine inverse x, one was cos inverse x. So cos inverse x was same, but there was negative sign. So what you can do is, you can keep the same formula for like 1 minus x square, but it can also be written as minus cos inverse x plus c. Okay, so you can see 1 by root under 1 minus x square can be sin inverse x or minus cos inverse x. Similar to that, one more thing is there. What was that? Let us say next one is dx by 1 plus x square. So 1 plus x square was what? Tan inverse x. So it will become tan inverse x plus c. However, same formula can be written in terms of cot also. So x square can be written as minus cot inverse x. Then if we see sec inverse x, so integration of dx by x root under x square minus 1. So x square minus 1 will be what? Sec inverse x plus c. Then next one, same formula, it can be in terms of cosec inverse, right? So dx by x root under x square minus 1 can also be written as minus cosec inverse x plus c. So why I am saying you these sec inverse as well as minus cosec inverse is sometimes you need to write minus cosec inverse to suit the solutions. Okay. Now if we talk about exponential, so let's say 14th one is integration of e to the power x dx will be e to the power x, same it will remain because differentiation was also same, so integration will also remain same. Now integration of 1 by x dx will be what? Log x plus c. You had seen that it was log x plus c. Next one is integration of a to the power x dx. So that we had seen a to the power x by log a plus c, because differentiation was a to the power x is equal to a to the power x into log a, so log a will become down. So this was all about like different formulas for integration and differentiation. In the next session we will try to understand some properties of integration and based on that some problems. Thank you so much.